So today I'm going to prove that the reverse derivative is just the integral, or the area under the curve is just the reverse derivative. And here's how we're going to do that. So the area under, so how does that prove that? Well, derivative of f of x, if we take an integral of it, that means if we take a reverse derivative of it, oh sorry, my battery went low. If we take a reverse derivative of this f prime of x, it should just go back to f of x, because that's what a reverse derivative means. So yeah, we're trying to prove this. So let's say, remember, f prime of x is also a function in itself. So let's say this is y equal f prime of x, right? And we want to stop our area at some x value, because if it goes on to infinity, the areas can be infinity, and we don't want that. So we're going to stop it at some x value. We're going to separate these into multiple rectangles. If you watch my previous videos, you know what method I'm going to use. We're going to make each of these rectangles have a base b, and we're going to sum all these rectangles together. So the first rectangle would have a base of b, or this rectangle right here, and a height of f prime of b. Because if we plug in b, we get f prime of b, and that's the height, because y equals it. And the second rectangle, or this rectangle right here, which is not much different than the first, will have a height of f prime of 2b, and a base of b. And yeah, you guessed it, the next rectangle will have a height of f prime of 3b, and a base of b. And we want b to approach 0, because it makes our thing more accurate. Alright, limit as b approaches 0, and the area of the first rectangle would be b times f prime of b, or base times height, and so on with the rest. Dot, dot, dot. Oh yeah, and this last rectangle will have a height of f prime of x, and a base of, will still be b, so an area of b times f prime of x. Alright, now let's factor out this b. So we get that lim b 0, b, f prime of b, plus f prime of 2b, plus f prime of 3b, dot, 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 all the way until we get to f prime of x. We factor out b. Now, the derivative of an f graph can also be defined as something else. So if you've took calculus, you'd know this definition. F prime of x equals lim as b approaches to 0, f of x plus b minus f of x over b. And it doesn't matter what variable you use. You should only make it approach 0, and it will work for anything. So let's convert this f prime of b here into this form. So how are we going to do that? Well, we just plug in b here into x. So here's what we get. F of 2b, because b plus b is 2b, minus f of b over b, plus the next term is here, 2b into x, we get 3b, because 2b plus b is 3b, and so forth. We plug in 2b for x over b, and so forth. But look here. These terms all have a denominator of b. So this, if we distribute it into all of these terms here within this parentheses, we just get the numerators on the top. And this will look something like this. F of 2b from here minus f of b plus f of 3b minus f of 2b. And if you want to go forward even more, then plus f of 4b minus f of 3b, all the way until we reach plus f of x minus f of x plus f of x plus h. F of x plus h would be the final term of this sequence because, look here. If we plug in x into this formula, plug in x for x, we'd get, oh, sorry, this should be a b. If we plug in x into here, we get f of x plus b minus f of x, and nothing can cancel out this because this is the largest term. We're stopping at x. So, look. There, yeah, nothing can cancel out this. So, we get that this cancels out with that, this cancels out with that, and this is going to be canceled out with some term that we haven't written out yet, but know that f of negative f of 4b is within here. So, oh yeah, and this cancels out with that. So finally we get this formula of f of x plus b. These are the only things that remain. This equals the area under the curve. And as the limit b approaches the 0, we get that area equals f of x, because x plus 0 is x, minus f of 0. And look, we know for certain that the integral of f prime of x dx equals f of x minus f of 0, because an integral is just the area under the curve. But look here, it also is equal, the integral of this f prime of x function equals the original, or from the integral from 0 to x equals this. So we have proof that an integral is just the reverse derivative, because if we take the derivative of this function, we get f prime of x, and if you apply it at 0, this just becomes 0, and then we take an integral, we get back to this function. All right, thank you.